Hello students, as you all know that we are doing phenol, in which we have finished the preparation, then the physical property. After that we did the chemical property, in which we have finished side chain reaction of phenol and nuclear reaction of phenol. In A we did side chain reaction of phenol, in B we did nuclear reaction of phenol. Now in C we'll do special reaction of phenol under chemical property of phenol. So now we're waiting towards C, the chemical property of phenol. Okay, and that is special reaction of phenol, and it is very important for 2021 board exam, special reaction of phenol. Okay, now let us see what are the special reaction of phenol. Number one special reaction of phenol is referred by the name Kolbe's reaction, and number two special reaction of phenol is known by the name Reimer-Tiemann reaction. These are the two special reactions of phenol. Actually there were many, but it has been removed from the reduced syllabus, so you just have to learn two special reaction of phenol, students. So let us go with the Kolbe's reaction first. With the help of Kolbe's reaction, okay, we can prepare salicylic acid from phenol. We can prepare salicylic acid from phenol. So phenol is acidic in nature, as you all know. Phenol is acidic in nature, as you all know, isn't it? Phenol is acidic in nature. So this is the formula of phenol: benzene ring with OH is called phenol. This is your phenol. So first of all, phenol you react with sodium hydroxide. You have to react phenol with sodium hydroxide. So when you react phenol with sodium hydroxide, now you have to remember one thing, that phenol is acidic in nature. I have explained you earlier, and it's reacting with sodium hydroxide, which is a base. So when acid and base reacts, we get salt and water. So this H of phenol goes with this OH of base to form water. H2O, water. H2O, water. Then this, in place of this H, this Na will go to form ONA, and you get benzene sodium phenoxide. Okay, so in place of this H, Na will go to form sodium phenoxide in Kolbe's reaction. Now once you get sodium phenoxide, we react it with carbon dioxide. Okay, we react it with carbon dioxide. You have to remember the temperature value is 400 Kelvin. Pressure required is 4 to 7 atmosphere pressure. Okay, so now this sodium phenoxide, which is formed by reacting phenol with sodium hydroxide, reacts with carbon dioxide at 400 Kelvin and 4 to 7 atmosphere pressure. So when you do so, this carbon dioxide will go and reside between O and Na. So between O and Na, who will go and reside? Carbon dioxide, means COO. COO will go and reside between O and Na, carbon dioxide. Now you can see how many atoms are here. 1, 2, 3, 4, 5. 5 atoms is hanging in one place, so this, which makes this compound unstable. So as this compound is unstable, it undergo rearrangement reaction. If this compound is unstable, so it undergo rearrangement reaction. In rearrangement reaction, what happens, students? In this corner there is CH, 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 CH. So in this corner there is CH. So take the H out from here. From CH, take out H. Now when you do rearrangement, students, this portion will come out here and H will go up. As a result, you will get OH, and this CONA will come down. This compound is known by the name sodium salicylate. This compound is known by the name sodium salicylate. Now finally this sodium salicylate, students, okay, finally this sodium salicylate is reacted with dilute HCl. So when you react with dilute HCl, what happens here? This Na will go with this Cl and forms NaCl. Minus NaCl means NaCl is out. So as NaCl goes out, this H will go in place of Na and forms like this. This H will go in place of Na and form like this. And the compound so formed is salicylic acid. This compound is referred as salicylic acid. So do remember, with the help of Kolbe's reaction, we prepare salicylic acid. If you want, you can repeat the video to understand better. So by this reaction, Kolbe's reaction, we prepare salicylic acid from sodium phenoxide. So do remember, I have shown you the reaction from phenol to salicylic acid, but actually the Kolbe reaction starts from sodium phenoxide. So it starts from sodium phenoxide and it ends in salicylic acid. So from sodium phenoxide to salicylic acid is referred as Kolbe reaction whereby we convert sodium phenoxide to salicylic acid. But usually the question comes how to convert phenol to salicylic acid. Then first you react phenol with sodium hydroxide. This red one is not Kolbe's reaction. I'm showing this extra. So when phenol reacts with sodium hydroxide, you get sodium phenoxide. So as soon as you get sodium phenoxide, then you can proceed Kolbe's reaction to reach to the salicylic acid. So from sodium phenoxide to salicylic acid is Kolbe's reaction. This is an extra portion which I have shown you so that you should learn how to convert phenol to salicylic acid, students. Okay, and this is very important reaction, students. So now the question may come like this from here. Okay, sodium phenoxide is converted to salicylic acid by which reaction? So answer is Kolbe's reaction. Or they may say due to Kolbe's reaction, what of the following compound is prepared? So answer is salicylic acid, and to remember its formula. So this is all about Kolbe's reaction, the special reaction of phenol. So you can repeat the video to understand better. Now we go to the second special reaction of phenol, and that is referred as Reimer-Tiemann reaction, students. Reimer-Tiemann reaction, it has been asked in sample paper. How the question has been asked in sample paper, I will show you later from Reimer-Tiemann reaction. First, let us go with this. With the help of this reaction, we introduce aldehyde group in phenol. So do remember the contribution of Reimer-Tiemann reaction is to introduce aldehyde group in phenol. So we introduce aldehyde group in phenol with the help of Reimer-Tiemann reaction. Now let us see what is it. This is your phenol. And for Reimer-Tiemann reaction, these two are referred as reagent. Okay, these two are referred as reagent. So the reagent of Reimer-Tiemann reaction is chloroform and aqueous KOH. This is the formula of chloroform, students. And this is your aqueous KOH, and you react this in acidic medium. Acidic medium means H plus, and here the acidic medium uses actually dilute HCl, but you can simply write H plus. So now Reimer-Tiemann reagent is chloroform and alcoholic KOH, do remember, and it reacts with phenol whereby aldehyde group is introduced in phenol. Now in this phenol, in this corner there is H, take it out. In this phenol, in this corner there is H, you can take it out. Now when you react phenol with chloroform and aqueous KOH, which is the reagent of Reimer-Tiemann in acidic medium, in this place H will get removed and aldehyde group will get introduced. Here H will get removed and aldehyde group will get introduced. Now you can see aldehyde group has been introduced in phenol. Therefore, this is Reimer-Tiemann reaction. Now other products. This K will go with this Cl. This K will go with this Cl to form KCl as one of the byproduct. This OH goes with this H to form water. So in place of this H, aldehyde group will come. K and Cl will form KCl. This OH goes with this H to form water. And this carbon which was here in chloroform is here, students. So with the help of Reimer-Tiemann in reaction, we introduce aldehyde group inside phenol, and the reagent is these two, chloroform and aqueous KOH. Okay. Now we have to balance this equation. So let us balance it. When you balance the Reimer-Tiemann reaction, students, you start from chlorine or halogen, you can say. So here are 3 chlorine. So I'll put here 3. So 3 chlorine balance, 3K balance, 1C balance. So I balance potassium, chlorine and carbon. Now let us balance oxygen. Here is 3 oxygen and here is 1. Total 4. So here if I put here 2 oxygen, 3 oxygen, 4 oxygen, balance. Now what is left to be balanced is hydrogen. Okay. Hydrogen count here 1, 2, 3 plus 3, 6. So here 2 2s are 4, 5, 6. Everything is balanced, students. Now what is the name of this compound? This compound is known by the name salicylaldehyde. You can see from here, students. If here is OH, here is also OH, here is COH, so we say salicylic acid. But instead of COH, here is CHO. So it's aldehyde. So instead of saying salicylic acid, we say salicylaldehyde, whose IUPAC name is like this. In this two, do remember aldehyde get preference. Okay, aldehyde get preference in alcohol and aldehyde. Aldehyde gets preference. So we count from here 1, 2, 1, 2, 2 hydroxy, 1, 2, 2 hydroxy, and this is called benzaldehyde. 2 hydroxy benzaldehyde. Benzene ring with CHO is called benzaldehyde. So salicylaldehyde is also known by the name 2 hydroxy benzaldehyde. So the question from here may come this way, student, in Reimer-Tiemann. Which reaction introduced aldehyde group in phenol? Answer, Reimer-Tiemann reaction. What is the reagent of Reimer-Tiemann reaction? Chloroform and aqueous KOH. Okay, so when phenol reacts with chloroform and aqueous KOH, okay, what is the name of this reaction? So answer is Reimer-Tiemann reaction. And what is the product form? Answer is salicylaldehyde if it is given in the option, or 2-hydroxybenzaldehyde. This has been asked in the sample paper, students. Okay, so you can see that sample paper. I will show you later on. Now there is another important note to be remembered. This Reimer-Tiemann reaction can be modified. Okay, Reimer-Tiemann reaction can be modified, students. So now I'm going to show you is the modified form of Reimer-Tiemann reaction. So in modified form, you can see here is phenol, here is phenol, here is aqueous KOH, here is aqueous KOH, acidic medium, acidic medium. In normal Reimer-Tiemann reaction, we use chloroform. Now remove this H from chloroform. Remove this H from chloroform. What is left? CCl3. In place of this H, again add chlorine. So it becomes CCl4. That is carbon tetrachloride. Just replace this H with one more chlorine, you get carbon tetrachloride. So instead of chloroform and aqueous KOH, if you use in phenol, you get aldehyde group is get introduced, and that is normal Reimer-Tiemann reaction. But instead of chloroform, if you use carbon tetrachloride, the two reactant is same in acidic medium. Then if you use this, you get acid group, carboxylic acid group will introduce in phenol, and this is called modified form. Now let us understand what is this modified form of Reimer-Tiemann. Now this is the reagent of modified form of Reimer-Tiemann reaction, students. And in this corner there is H we can consider, because in all corners there is CH. This is your phenol. Now when you react, in place of this H, here acid group will get introduced. COH is acid group get introduced. This K and Cl comes out as KCl. And this OH will go with this H. This OH will go with this H to form water. OH and H forms water. Now when you balance this equation, you start from halogen. So here is 4 chlorine. So here is 4 chlorine, 4 potassium, 4 potassium, 1 carbon, 1 carbon. So I have balanced potassium, chlorine and carbon. Now balance oxygen. Here is 4 oxygen with this 5. Now here if I put here 2, so here is 2 oxygen, 3, 4, 5, balance. Now hydrogen is left, 1, 2 plus 4, 6 hydrogen. Here is 2 to the 4, 5, 6 hydrogen, balance. So everything is balanced. And this compound so formed is called salicylic acid. Earlier was salicylaldehyde. Now this is called salicylic acid. Whose IUPAC name? Again in this two, do remember acid gets preference. Okay, acid gets preference. So we count from here 1, 2, 1, 2. So in 2 what is hanging? Hydroxy, 2 hydroxy, 2 hydroxy. And benzene ring with COH is called benzoic acid. So this is called 2-hydroxy benzoic acid. So students, now do remember about Reimer-Tiemann. If you use chloroform and aqueous KOH in phenol in acidic medium, aldehyde group will get introduced and you get salicylaldehyde or 2-hydroxybenzaldehyde, the IUPAC name. But if you replace chloroform with carbon tetrachloride, it becomes modified form of Reimer-Tiemann, where instead of aldehyde group, acid group will get introduced and you get salicylic acid, whose IUPAC name is 2-hydroxybenzoic acid, students. So these are the two special reactions of phenol. Now you can see from here, students, there are two ways to convert phenol to salicylic acid. You can convert phenol to salicylic acid by Kolbe's reaction, or you can convert phenol to salicylic acid in one step by modified form of Reimer-Tiemann. So there are two ways to convert phenol to salicylic acid. One is by Kolbe's reaction, one is by modified form of Reimer-Tiemann, and both are very, very important, so do remember this. So the question which came in sample paper was from Reimer-Tiemann reaction, normal. Okay, so in Reimer-Tiemann reaction, phenol, chloroform and aqueous KOH reacts, but in the sample paper it's written alcoholic KOH, which is wrong. It should not be alcoholic potassium hydroxide, it should be aqueous. So in the question paper, it should not be alcoholic, it should be aqueous. And the product so formed, there are 4 options, so the answer is salicylaldehyde. You can see, okay, the question paper. So hope so you understood. So by this, we come to the end of special reaction of phenol as well as with the property of phenol. So students, we have finished all the 3 special properties of phenol. One was side chain, one was nuclear, one is special reaction of phenol along with the preparation. Now what is left for phenol is the test. Once we do the test for phenol means, okay, this chapter is over called ethyl alcohol and phenol. So now in our next video we will do the test for phenol and we end the chapter called ethyl alcohol and phenol. Thank you very much.